Chapter 8, Statistics, Collecting Data. Statistic is a collecting, organizing, summarizing, and analyzing information so that intelligent conclusions are made, using data to draw conclusion or answer questions. In 8.1, we learn about population and sample. Population is the data we collected and trying to describe certain characteristic about it. And while we try to analyze what population is, usually it's not feasible to ask every single person in that population. So we end up taking a sample. So a sample is a subset of a population. Example here, a dentist professor really wants to see if 4 out of 5 dentists prefer Dentalin gum over any other gum at a dental school. What would be the population? So the population would be all the dentists at the dental school. Then the sample would be the couple people that we interviewed for. Now you know the difference between parameter and statistic. A parameter is basically a number or numerical value that describe your population, while statistic is a numerical value describe a sample. For example, we can say the students at the entire college has an average GPA of 3.2. Now that 3.2 describes the entire college, so we call that a parameter. If I say if we just randomly pick 10 students from the school and find their average GPA, then that GPA will be a statistic because I'm only asking 10 people, not an entire college. Here's a couple of examples. To determine average length of a trout in a lake, researchers catch 20 fish and measure them. So the population will be all the fish in the lake, and the sample will be the 20 fish. Now, once we collect the data, we can categorize data into two, either categorical or quantitative. Categorical basically are non-numbers, and quantitative are numerical values. For example, gender is categorical, right? Male, female. Okay, temperature is quantitative because it has numbers. Number of time a college student work out in a 7-day week is also quantitative. So these three examples here are really obvious. The numbers are quantitative. These data involve numbers, and this data involve words. But now let's look at this one, D. This one is especially different. Even though a zip code is a number, but when we talk about number, when we talk about quantitative data like heights, those are the numbers you can add, subtract, multiply, or divide. Zip code, you can really add, subtract, multiply, divide, and make a meaning out of it, because zip code could be easily replaced by the place name. Right, so some numbers are just identifiers, like zip code, your ID number, or area code, or your phone number. Any of those numbers are not true number in the sense that we can work with it using traditional add, subtract, multiply, divide. So those numbers are considered categorical, and hair color definitely categorical. So how do we get samples? So sampling method. There are many different ways we can get samples. So since we try to study the population, okay, then when we try to study population, then we cannot. It's counterintuitive to try to ask every single person. So the idea of statistic is ask only a couple people and taking that data to extrapolate it into what population might look like. Okay, so the question will be, how do I pick those couple people so we are not going to generating what we call sampling bias. We want to make sure we collect data from all the populations that's so entire population will be represented. Like, for example, if you want to find out how the whole United States feel about certain issues, we don't want to just ask all the people in California, because that's definitely biased. We want to try to maybe pick 100 people randomly from each state, maybe, or any other methods. Okay, so the different methods right here. Okay, they have Then where are the methods? Right here, the sampling methods. Okay, so the most important thing about this section is knowing the difference between these sampling methods. Okay, so as you're reading through the examples, definitions, and then here's an example of them. Okay, now the most important one to know the difference is a stratify versus cluster. Now, quota is just a special type of stratify. Now, stratify sampling versus class sampling. What's the difference? Both of these require you to take the population and divide it into subgroups. For example, stratified sampling, like the previous example I was talking about, if we take the entire United States, divide into 50 states, and then we then ask 100 people randomly from each state, that's stratified. Cluster will be divide the entire country into 50 states, but we only ask all the people in California. So the difference between the two is for stratified, we ask some people from all the groups, while clusters is we ask all the people in some of the groups, right? So they are the opposite of each other. But remember, both of these involving dividing into subgroups. Okay. Now, systematic sampling is easy to spot. It's at so imagine we want to ask the student in this college that what's their favorite drink is. Okay, then how do I, instead of asking everybody, I can pick a random number, say 10. So I can ask every 10 people that come into the on campus during the morning hours, and I ask those people. So every nth number, every 10th, every third, every 15th, whatever the number that you decide to do. Convenient sampling is what you don't want to do. Okay, so is volunteer response sampling, because both of these, convenient sampling means you basically just randomly ask people without thinking about is it going to create bias or not. And volunteer response is only if people bounce back to you, and those are the data you collect. But sometimes that creates a bias because the people who volunteered might not represent the entire population you try to study. And then so read these couple examples. He has an example of each type of the kind of further examples of the type of sampling methods. Okay, so how to mess things up. So like I talked about it before, sampling bias, volunteer response, self-interest study, response bias, all these are creating issues, and these are the things we try to avoid. And then following that, we have a couple examples of, they kind of give you an example, like a scenario when you do these, and these are the things